Now let's talk stratigraphy. So for this video, I'm going to be focusing on a relative dating technique that is basically the foundation of all dating techniques in archaeology. It's also critically important because of the role stratigraphy plays in understanding context. So this goes back to our excavation methods, that a good stratigraphic excavation will help us provide us with a reliable relative chronological sequence for the deposition of the different layers or strata or sediment within the archaeological site. Now, this is important because, as I state here, if we later on then date something from one of the layers or one of the deposits using an absolute or chronometric dating technique, then the whole deposit can be dated by association. So let's look at our picture here where we have some fossils represented, and let's say that we were to date this little fishy here using radiocarbon dating, or the bones here we're using radiocarbon dating. We would then be able to date everything else in this strata in association with the fish bones by association. But before we talk about stratigraphy then, and then how we figure out what is explained here in terms of the further back we, or the deeper we dig, the further back in time we see, we need to look at the principles of stratigraphy. And these are brought to us courtesy of the work of Nicholas Steno, and they've since been built upon them. So we're going to look at the principles or the laws of stratigraphy, beginning with the law of superposition, which, as stated here, is simply that layers are successively deposited one after another such that the oldest layers are on the bottom and the youngest are on the top. And often, for analogy, to explain the law of superposition, we talk about cakes or sandwiches, right? So if we imagine the bedrock, which is the base level in which all sediment is deposited, is our plate. If we want to make a sandwich, then the oldest layer that we are going to deposit is going to be our piece of bread. So we place that down. Then we are going to spread some peanut butter, because I want a peanut butter and jam sandwich. So we're going to lay that down. Okay, so the peanut butter, because it was deposited after the bread, based on law of superposition, this tells us that the peanut butter must be more recently deposited than the layer of bread, because the peanut butter has been built upon, as it were, or deposited upon that layer of bread. Then we can add a layer of raspberry jam. So now we have 3 layers. Raspberry jam is now our most recent. Then the next oldest is, after that, is our peanut butter, and then the oldest is still our initial layer of bread. And then finally on top we can slap our layer, our final capping layer of sediment, or our piece of bread, to complete our sandwich. And so the sequence of deposition, beginning with the most recent, which is now on the top, we have bread, then raspberry jam, then peanut butter, then bread again being placed on top of our plate. Okay. Why a sandwich analogy or even a cake layering analogy works relates to the next law, which is that of original horizontality, which is the deposits are laid down horizontally on top of each other. And this means then if we see any sort of deviations in our strata, if they're not horizontal anymore, that there's some sort of uplifting or downfall that has occurred. And of course, as archaeologists, we then have to think about how other C and N transforms might be impacting the sediments themselves. We then have other principles that we need to look at. So I already mentioned association, or the principle of association, where those items that are found together within the same depositional unit, within the same strata or layer, are essentially the same age. Of course, as archaeologists, we have to be kind of a bit cautionary on this, because we do have our curatorial or archival behavior in humans, right? That we might have some sort of treasured object that we then carry forward with us. So it could be a lot older, right, than the associated objects it's found with, right? Many of you in your homes might have an object that is quite old compared to the house itself, right? We have the principle of reversal. This is very rare, but occasionally deposits can be removed from the site and redeposited in reverse order. You can imagine this might happen with digging some sort of pit feature or trench, perhaps a hole for a midden or an outhouse. And of course, this relates then to the last principle, the principle of intrusion, where that whenever there's an intrusion, it must be more recent than deposits through which it cuts, right? And this makes sense. You can't cut into a layer sediment that doesn't exist, right? You can't put a hole into air. right? And so often ovens or underground ovens or garbage pits, wells, again, middens, outhouses, foundations of houses and walls can all be intrusive into older deposits. So clearly in archaeology, when it comes to using stratigraphy as a relative dating technique, the law of association, or the principle of association, are key. One of the things that's kind of useful, although it can be frustrating initially, is that if we do have older material above younger, or these kind of oddities in relative dating, it lets us know something about those site formation processes, right? That for older material to be found above younger materials in a deposit, then there's a secondary context that's happened, right? Something has been disturbed, something has been moved from that in situ context. And so here's an example of a famous tell site, which is all these layers of occupations that have been deposited one on top of each other, and it's illustrating some intrusive deposits. It's illustrating the principle of original horizontality, and then it's giving you a couple of different dating techniques that could be then used to date the various deposits, right? So there's a coin that dates to 1910 AD, or sorry, a cushion coin that dates to the 2nd century AD. There's another artifact or something called Anna that dates to 1910. We have a Harappan seal that dates to the 3rd millennium BC. And so even though all of these three pieces of material culture are all in this, appear to be at the same level or the same depth from the surface, clearly they date to different time periods, because, again, these principles of intrusiveness, the association with other objects. So let's look at an exercise. So here's a stratigraphic profile that I've drawn. So we have bedrock on the bottom, and then we have various strata and various intrusive deposits that have occurred. So how would we go about reconstructing, again, using a relative dating technique, which of these deposits is the older, which one's more recent, and then all the ones that fell in between? Well, the first thing we need to do is identify layers. And in this case, I've just randomly assigned letters to the various layers of sediment. So we have A, B, C, D, E, F, G, H, and I. Okay, so that's the number. And so I just kind of started with the clearest units, and then went back in and looked at various sorts of cuts and fills. And so in this case, I've treated cutting events or intrusive events separately from the events that infilled them. So this will become a bit clearer as we walk our way through it. So now we can identify the sequence of deposition now that we've layered them. So bedrock's on the bottom. Again, it is our plate in our stratigraphy sandwich. The next layer of sediment that is found on top of it is D, and so we have this horizontally deposited unit, so that's going to be our oldest. So we're going to start there. Now we have to decide what is next oldest. Well, the next kind of entire kind of continuous strata or deposit is C, but in between D and C is this here. We have the cut represented by G, and then we have H, which is a sediment that is filled into this hole. So using the principle of intrusion, we know that G must be more recent than D. Because G is below C, it must be older than C. So our sequence now is D as the oldest, followed by a cut into D, which is G. That cut or that pit feature is then infilled, which is H. And then all of this is then deposited over by C. Okay, so those are our first four strata or units. Then again, we can look and see, okay, what other ones are clear? Well, we have this kind of lens that is here represented by B, and then we have this whole thing, this whole strata referred to as A. Well, because A overlaps both B and C, that means B must be older than A, right? So that's the next part of our sequence. So we have D, G, H, C, B, A. And the reason why we know that this last part here, or E, this last cut, must be more recent than A and C and B is because it is intrusive again into these two units, right? So then we have E, then some rocks were dumped down into this pit, so that's I, and then finally we have the sediment filled in with F. Okay. So that is how I would go about looking at a stratigraphic profile in an archaeological site, right? I would take photos of it. I would then draw it. I would map it out, right? And then I would describe the various stratigraphic units and then attempt to reconstruct the sequence of deposition.